Good morning, everyone. Thank you for joining this session. That was the official signal that we can start. Thank you for being here. I think it's the second session of the day. So I'm trying to convince or motivate you today to use Apache Spark again, or even more if you're a Spark user for data pipelines. The fun thing I'm trying to motivate you is like, I think after 45, 50 minutes in this session, you will be able to do stuff like this, which is like all the planes flying over Europe. That's a snapshot, like I did this obviously like a week ago. But like, I think in the time of what it takes, you know, to have a coffee, you will be able to do the same thing. Not this animation, because the animation you can just Claude code. That's never the point, you know, UIs these days, they're just, you can easily do them with AI, but the data, it's always about the data. So getting to the live data of all planes currently flying using Apache Spark Declarative Pipelines will be more the hello world hands-on example that I want to show you. I'm Frank. I work for Databricks. I'm not sure if you know Databricks. It's the company that, well, the data and AI company we want to be. Company that kind of was the, our CTO was the initial committer of Apache Spark. Other open source projects are MLflow, Delta Lake, Delta Sharing, now Unity Catalog, and now Spark Declarative Pipelines that we kind of committed and open sourced. So I spent a lot of time in my past working on large-scale compute, like high-performance computing, and doing research in this area. And then I kind of switched and, you know, talked about big data in the early Spark days. And I literally went to one Vox days in Switzerland, where I was like still at AWS and talking about like, what would you do with 1 million cores? And everyone is like, who has 1 million cores? You wouldn't even get that at AWS. But you did, you know, and then like 2 years later, I went back and was talking about big data instead of, you know, having a large amount, of course. Anyway, now I'm here and I want to kind of briefly motivate Spark, first of all. Not sure if it's necessary at all. I remember, like, my background is in dev, like Java Enterprise, and I remember when I saw Spark the first time and understood, like, you could just, you know, read from any directory with any number of JSON files, with any number of records, like, you know, car users, in one line, and then just apply filters and say, now give me all the people who drive an Audi car. And like, wow, this is so cool, because it's like one line. And then if you wanted, you could just do the same thing in SQL, obviously in a SQL cell. And then if you run this in the right environment, in one notebook, you can combine SQL cells and those Python cells and like just be opportunistic like I am and use what is the easiest for a particular task. And having told you that I spent time in high performance computing, where we spend a lot of time thinking about what if you have big data sets, and I was working on these brain imaging things that you sometimes see in magazines, like, you know, this is the area that glows up if you listen to rock music versus classical music, or if you think about something positive versus negative, or if you feel pain or don't feel pain. This was a data-intensive and an embarrassingly data parallel problem that we solved very often in a manual way of distributing the data and computing the results and collecting this and putting it together again. Today in Spark, you get this parallelization and scaling automatically. And that's a lot of, you know, if you just do these entry-level hello world things, you don't even notice that because it happens behind the curtains. But even this tiny example is spread across a cluster, and it would scale, and that's the big promise of Spark, obviously, the scaling. And then the other thing is, if we go from static data, reading a JSON file from a folder, to streaming data, something that comes from Kafka, the difference is very, very small. You just change this read.format JSON to something like read stream format Kafka. And you do the same thing. And I remember doing Kafka in Java. I remember doing a Kafka tutorial like in my other days at AWS. It was like a long tutorial, and then people kept slacking and emailing me, hey Frank, can you send me a client that reads from Kafka? And now I feel like, yeah, just do spark.readstream format Kafka. So it has become like super easy, and the difference between reading static things versus reading streams is like almost negligible. Okay, now if we kind of expand this to the bigger picture, to the more enterprisey picture, how does this look like? And you see it says Databricks here. I stole this slide from our marketing folks who are brilliant in creating slides. How does this look on an enterprise level? Well, you have like thousands of data sources which can be categorized into cloud storage, message queues, databases, enterprise applications. And this is your input data source, and you have your use cases like AI these days, simple dashboard, real-time applications. But in between, we do the classic, data engineering. You need to ingest, you need to transform the data. There might be some real-time processing, and then there's typically more than just one task. And this is why you have to do orchestration as well. So that's the big picture. And now, you wonder, isn't that already possible with a Spark? Excuse me. And the answer is yes, it is possible. And a part of this presentation today is also about simplifying Spark. Now, a lot of people talk about, I want to simplify, I want to build a framework on top of something existing. And in this case, it's literally the project that was done by the same folks who did Spark streaming. It's Michael Armbrust. He's still a principal engineer working at Databricks. And he was like, he built that now it's like 13 years ago, I think. Looking back at 13 years, looking back at like tens of thousands of customers that he was dealing with, what would improve today? I'm kind of emphasizing this because very often we have these people building abstractions, and then you wonder, why are you building that? And in this case, I think the bar is even higher if the person who built the original project says, look, this is how I think we should do it today. So why simplify? I'm going to explain you why simplify. And then we have this declarative in the name, Spark Declarative Pipelines. What is declarative? I'm going to answer this right now. So first thing, what is declarative? Remember, I was telling you about how easy it is to read from Kafka, this Spark read stream from Kafka. Imagine you have this order tables, it comes from Kafka. So we have this classic, we read from Kafka, we define, the broker, the topic, what we want to read. We apply a filter, and then we say, okay, now go and write this to any database table, iceberg, delta, whatever. If you think about this, a lot of code, and then we say start. Well, the thing is, the first part of this code, we declare a plan, we declare what we want to do, but it's not doing anything until you do this .start. So we have a plan, and then we execute this plan, and this is what I want to see as declarative. So the other thing is, if it's declarative data pipelines, what is a data pipeline? Well, the thing is, a data pipeline is if things get a little bit bigger, because it's like something that produces and updates a set of data sets. So what you've seen in the previous slide, we create one data set, now we have a set of data sets. So it looks like this, and then the question is obviously, where do these data sets come from? There is a query that is creating those data sets, and then there is some order of execution for these data sets. And then typically, I don't know, I find it interesting enough, but typically the non-technical people then always point out that's a DAG. All our marketing people want to overemphasize this is a DAG. So we have this DAG defined, which is technically true. You could call it a workflow, just a flow. And this is what you want to execute as a data pipeline. And now the question is, why am I standing here? Why did I fly in from Munich? Why do I think we should make data pipelines declarative? Well, the answer is because pipelines are hard. They're actually really hard if you look into the details, surprisingly hard. I gave you this example for a single data set, but let's look at something a little bit more complicated. Again, we have this orders table that comes from Kafka, And then think about having a second data set, which is kind of backed by the most important data technology we have in the world, which is CSV and Excel. And then obviously you want to join these two things, like the stream that comes from Kafka and the table, the customer's CSV file, and you want to join this and create this fact orders. Well, if you do that, you have like not one starting point where you kick the thing off, but you have like 3 starting points. And then the question is like, how would you run that? Well, the answer is just put in one file and run it, run this, run this, run this. And why not? You know, what's the big problem? Well, the thing is, if you do it this way, you probably realize you could have run the first 2 things at the same time, the first 2 blocks. And maybe it's not a big problem if you have like 3 of these data sets, but it might become a problem if you have like 100 or 1,000 or 300. And there's literally like lots of data pipelines out there where there's hundreds of data sets involved. So at a small scale, possible. At a large scale, this is not the optimal way. Well, then probably, I assume you're much better coders and software engineers than I am. You probably say, well, we can solve this problem by just adding threads, you know, just start up a thread, run those things that can run in parallel in threads, you know, so they are run concurrently, and then define the threading. You start the threads, you define where they should start and stop. And then for something like this pipeline that I'm showing you here, it looks more or less like this. And don't focus too much on the single lines. It's just to, you know, to motivate what we are doing. So at the end, you're writing code to define the concurrency and actually to create the concurrency for such a data pipeline. Now, it depends if you're a very technical person and enjoy doing that. There's maybe nothing bad about this. If you're a manager of, you know, 10 people doing that and you think those 10 people should focus on data, on like the data transformations and like, you know, how to access Kafka, how to get to these tables, and not do the technical infrastructure platform threading thing, I wouldn't disagree either. So I think this is probably a lot of extra technical things that should not be done manually. And remember, this also needs to be maintained. If you change your pipeline, you need to change this threading code. The other thing is, what if there is an error? Well, there's all kind of errors. There's this error that probably I would do if I didn't have enough coffee before I start coding. So you have something like custom ID here, and then we have something like custom identifier here. It's also something I would do if the last coffee of the day was too long ago. So I would do this in the morning and late afternoon. I would probably do this all the time. So you want to have something that catches these errors. And there's other errors. Think about not the ID errors, but some glitches that, you know, just happen and they would go away if you just retry. So you want to have a mechanism of retry. Now, you can obviously define a retry mechanism like with this decorator and then apply this decorator. And then at the same time, remember, you still need to do the threading. So there's a lot of infrastructure things you're solving by writing additional code. And then there's a third kind of retry. Maybe your pipeline is running, it runs perfectly well, and then like 1 hour later, your boss calls and says, look, the guy from department A said, it's all good, but they changed something, you need to rerun one particular data set. How do you get to one particular data set and rerun this? Well, you could add this, like you just define with a startup parameter what you want to rerun explicitly and add this to your code. So you see where we're getting. We're just having more and more of these things where I want to argue this should be infrastructure and not code, but we have them in the code. And then the last thing is probably if you do it like the way I'm hinting already that you should not do it, to improve this situation, a lot of people say, well, how about I define a workflow and then in this workflow I execute those bits and pieces that you see on the left-hand side, which means you separately create a DAG object the same way as you separately created the threading code. Possible, but probably not the best solution. And then the very last thing, I don't want to bore you, think about, again, this streaming ingestion from a Kafka source. then the streaming join with this static table. And maybe that CSV file is only, pulled or like ingested every 15 minutes. It's very easy to think about this execution. It goes like this. We don't need to focus on the code here. But imagine the stream is running. It's a stream. It's running all the time. So it's reading this orders table, and then the second stream is also running all the time. But maybe when the second stream wants to do the join, this CSV file that gets updated every 15 minutes hasn't run at all. Maybe just running in 15 minutes. So the join is technically not working. It's not just not getting any data. It's just not working because that table doesn't exist. So there is all kind of issues that we get if we try to expand this smaller model where we have a declarative approach for one data set and then, apply the error handling and the threading and all these other things manually in code. So the question is why are we not using this declarative approach that works really well for a small data set, for one data set, and apply it to the whole pipeline? Just build the plan first and then execute it. And you can guess, welcome, this is Spark Declarative Pipelines. So with SDP, and I kind of feel sorry for that slide, it's probably the worst slide in the deck. In SDP, technically, what we do a lot is we use these flows, but we don't really use them. And in all the examples I'm showing you here, you're not going to see a single hand-coded flow, because technically this flow is just connecting a source to a data set. And what we're using is very often higher level abstractions, such as those three. And from those three, you only need to focus on two. There's the temporary view, which is more an intermediate step in a pipeline that doesn't get persisted, that you would use if you want to, break up some logic into easier readable parts. But what we really want to focus on are those two: streaming tables and materialized views. And streaming tables, these are the two Lego pieces that you can combine together into one pipeline and use them as often as you want. I'm going to show you the whole pipeline example in a second, and the real code also in a second. Excuse me. So the streaming table is a mechanism to have a continuously updated table. So it basically connects to Kafka. It has state. It remembers what it has read already. So you can have a streaming table. You define it as create streaming table, reading from a stream, reading from Kafka, for example. It could be SQL, it could be Python. It does exactly once ingestion, and it does append only. So it always appends to this existing data, which also means you can use it for a lot of streaming operations and operations, I say, but not for everything. If you want to update existing data in such a table, it's not the right mechanism. But it's great for real-time incremental data ingestion. Think Kafka, think, you have an S3 bucket where you keep dropping the JSON files from the very first slide that I had with your card data. And it's cool for low latency streaming transformations. And then we have views, materialized views, and they're pre-computed and persisted based on a query. And the way to define them is simply create materialized view, and then you can have any complex aggregation in such a materialized view. And you use it for aggregation, periodically updated data, and it can possibly be incrementally computed. This is something which is just happening in the open source version and getting improved as we speak, but it's possible. Just think about, you have 1 billion rows in such a materialized view, and then there's 13 more coming, and you just compute the 13 extra rows, but not 1,000,000,013 rows. It's not always possible. So at Databricks, we have a huge team working on, improving this bit by bit by bit. But it's possible in many cases. And then, as I told you, we have these STs and MVs. You put them together. Very often you see those STs at the left side if you go from left to right of a pipeline, where you ingest, and then you have one more. And then you kind of have this. It's called medallion architecture, bronze, silver, gold layer. Bronze is where you ingest the raw data. You don't apply any crazy logic that could be wrong. It's just to get the data into the system, then the silver layer where you do your cleanup and aggregation, and then this gold layer that you present to, well, to the business folks, which is your gold layer for all the downstream applications. Right. You can do this in Python. Actually, to create a streaming table in Python, all you do is add this Python, table decorator. So it's import pipelines as, here's SDP, by the way. I'll tell you this in a second. And then the name of your table is the name of that function. You can overwrite this if you want. You can have a function X and name the table Y. But the default way is, just declare it as simple as possible. All you do is add this table declarator. And all the rest, if you look at this, it's like the normal Spark streaming code that you probably already know how to write. And then what I wanted to point out is, I think the convention, the naming convention has changed. So in Spark 4.1, in the official docs, I see this being imported as DP and not as SDP. Well, as DP, not as SDP. You know what I mean. DP is like what we should use. And you also see the DP name in the examples that I'm going to show you. Right, so if you have a more complex scenario, and that was the last one where you're rolling your eyes with all these extra things I told you we had to code. There is no extra threading, there is no extra DAG, there is no extra retries. It's actually all done by the system. There's also, no extra DAG. This is what I want to point out. The interesting thing here is like, how does this structure come together? If you have the fact orders here, which is this dev fact orders, it's a streaming table, which is combined from a materialized view and another streaming table. And if you see here, this is Spark read table customers, which is this customers table. So implicitly, you just use those, other streaming tables and materialized views. So the DAG is kind of in the code. If you change the code, you automatically have the correct DAG. I kind of want to see it like the DAG is like not an explicit thing. And very often, I remember, it was a product first, and then it became open source. So when we showed the product, people were like, I don't like this because you seem to drag and drop these things together. Like, no, we never do this. You write the code, and then, of course, we can visualize this pipeline graph, but we're not clicking this pipeline graph together. So it's code first in a declarative way, and then we can derive the rest, like giving you such a graphical view. Okay, then once you have this code, you just say Spark pipeline run, which is not the complete truth because you need a small YAML file that defines the location of your files and a little bit of infrastructure. But once you have this, you can just hit it with Spark pipelines run and then run your pipeline and you will get the output. So to summarize, you can, in SDP, you can do your transformations in Python or SQL files. For one pipeline, you can mix and match. You can start with SQL, and then you can do Python. You can be like me, opportunistic, and just use the language for one data set that is the most convenient one. Or you can be more strict and tell people, no, we only want to have pipelines with SQL, if that's possible. There is a Spark pipeline in it that creates you starting files if you want to do your very first project. Otherwise, you create this YAML file yourself. You have the transformations, and then you do a Spark pipeline run. You can do a dry run, which is checking the pipeline for consistency, but not writing any data. And then all this, what I talked about in length is happening automatically. It's done by Spark. And you can trigger one and the same pipeline in a batch mode, just trigger it every hour, every Friday afternoon at 2 o'clock, or you can run it continuously and it will keep pulling, the data. All right, so it's demo time almost, and that's good because we have a lot of time left. I brought you 3-4 different things I want to show you live and hands-on. Before I show you them, I want to explain what I'm showing. So I built the same use case, which is actually getting to this live avionics data in 2 different ways. One is the open source only VS Code, PySpark, nothing proprietary. The other one is using this free Databricks account that we have. It's a forever free account. You don't need the credit card. You can keep it forever. All you need to do is your Gmail address. Then you can do your Spark examples. You can play with all the other open source projects that we did, like Unity Catalog, like Delta. There will be, it's not an announcement, but like we're doing a Postgres database now. It's not in the free edition yet, but another selling point for this free edition will be that you will have a Postgres OLTP database as well. And of course, you can do Spark pipelines. There's some resource restrictions, obviously, because people would probably use it for other things than it is planned for. But it's a cool way of trying this in another way. And I'm not trying to sell you one or the other. I'm actually trying to show you both, and then you can decide which one you prefer. Okay, so the pipeline we're going to build is this Avionics pipeline, which gives you the data for the animation that I was showing when I started. The whole thing is this pipeline is incredibly small. It's one streaming table that is ingesting all the data, like the live data from all the planes currently flying, sending the IoT data, which is like location, altitude, direction, ascending, descending. Depending on which area we cover, it might be 10,000. If you do it for the whole world, it might be 40,000 planes at one point of time. This is the perfect thing for a streaming table. And then once we have the streaming table, which gives you the state, every time it kind of accesses the data, we want to have some summary, like how many planes did we see, how many events did we ingest, what was the maximum ascent, what was the maximum descent. So it's a perfect example for streaming table plus materialized view. Now you're probably saying, okay, but where does the data come from? Well, the data comes from open source. It's a community, it's a crowdsourced project where people have these small ADS-B antenna on their balconies and stream the data to a central location. OpenSky is in Switzerland. It started at ETH Zurich and Oxford University. It's run by a group of super cool people. You can access the data via an API. It's free for private and academic use. So it's literally those planes streaming the data to this endpoint, and then the endpoint is aggregating the data in an API, and we can conveniently access this API using a Spark data source. This is the last thing I want to cover. Excuse me. So the data source is like accessing Kafka. Remember, for Kafka, we had this Spark read stream format Kafka, and now all we do is Spark read stream format OpenSky, which means obviously the logic to get to this API and the retries and the authentication and everything is covered in this data source, which makes the streaming table small and cool, and it makes it kind of look like replace the OpenSky with Kafka, and you could read from Kafka. It's one of the newer technologies, and it's a nice way of wrapping access to third-party systems if you plan to reuse it. So I coded that, I open sourced it, and you can basically pip install it and use it from Spark Streaming the same way. And that's what I want to show you. Let's keep this away. Okay, so first thing, let's look into VS Code. That's VS Code. I coded the pipeline already, but now I'm showing you the real code. So this is the core thing where I say, look, this is the streaming table, dp.table, and that dp comes from pipelines, which is imported from PySpark. And then all I do is add this table decorator, which makes it a streaming table. I have this, the name of my function, and the function does the Spark read stream format OpenSky.load. And that's all. This is like 3 lines of code that give you the live data from all the planes flying currently. And I think the default is it's limited to the US region, while I'm getting my paycheck from a group that works in the US. So I thought, like, I make the default US, so let's make them happy. And yeah, that's the streaming table. And I have a materialized view as well. Well, obviously you see that's Python. And you also see there's a bit more than 4 lines because I need to import the data source. And then technically, because it's a Spark data source, I need to register it. I always say that's infrastructure things, so don't blame me for that. We have to do it. Well, we have to do it. So if you literally count the lines, it's more than 4 lines. In normal Spark, you also have to do this, session builder registered the thing. Databricks, you don't need that line, so it's a little bit shorter. But anyway, the core thing is 3 lines, and you get all this amazing live data. Then you have this amazing live data, and then you want to kind of aggregate it. And yeah, we have a materialized view for that. Now, I coded this in SQL, not because I had to, because I wanted to, because I wanted to show you we can have this mixture of Python and SQL. And this is like any aggregation. And the trick again is, I have this ingest flights, that was the streaming table. So I create a materialized view, give it a name, and basically I read from the streaming table, and then I define the aggregations that I want to do. Like how many events did we see? How many distinct aircrafts do we have? There is more events than aircrafts because every aircraft is sending an event like once per second or more than once per second. And then that's the aggregation. And yeah, there's one more thing. I told you there is this pipelines YAML file if you define it. If you name it, I think it's Spark pipeline YAML. And if you name it that way, you can also run it directly without specifying that extra name. It just tells where the storage is. So that's my directory. And that says, all the transformations, they kind of include all those transformations and the transformations, which is right here. And this is where the SQL and the Python file is. Okay, so once we have this, I should be able to do a Spark. Hang on. Did I change something here? No. Sorry, what did I do? Oh, thank you. That was just name, huh? Yeah. Okay, Spark. Pipelines run. Let's run it. So now it's basically, obviously, reading the YAML file. It's checking all the transformation it has, and it's executing a pipeline. It's doing a lot of, infrastructure stuff, checking stuff. It looks for a meta store. I'm using the Hive meta store, which is a switch that I also applied. And you see it's kind of detecting the data sets, and it says, this is planning, starting, running. So it kind of figures out the way to execute this. Now, the output is a Parquet file. It's classic Spark. I have this show results, which is, I can show you the show results as well. Let's see if that works. Look at this. Ladies and gentlemen, 10:32, which is right now. So there's a plane with this call sign coming from the US with this velocity and that altitude and that vertical rate. And like many, many more columns, and I just truncated them because otherwise it looks very ugly when I show it. But there is 20 columns altogether. And you can do all your stats and what's the craziest ascent, the craziest descent, where the most planes coming from. And again, this is the default region is US, so it's US internal planes now that we're seeing. But this is literally live data, and you can run this over and over again in a batch mode, or you can just make this pipeline in the config file as streaming, and you keep running it and ingesting continuously from that data. And then, let me downsize this. This is the materialized view. Number of events, 16,000. Number of unique aircraft, 9,000. This is what I told you, one aircraft is sending more and more events. So if I keep running this, it would be many more events, but not that many more aircrafts. And maybe the maximum ascent, descent rate would change as well. All right, so that's one thing I wanted to show you. Then if you, let me see where I have this. Yeah, if you want to go for that free account, you can set up the same thing, exactly the same code. The only thing that you don't have to do is write this YAML file. It's kind of what you configure here in this free account UI. So that's the Databricks UI. I don't want to spend too much time here, but you get a pipeline view, which is quite cool if the pipeline is more complex. You see here I had 6,400 ingested. The statistics here, I think it's a different implementation. It's not just aggregating to one line, but I think it's aggregating per country. So if I switch here, that's kind of the code view where you see literally this file browser, and then you can start having, your bronze, silver, gold, add folders here, like create a folder, and then sort this by your medallion architecture. You can run individual files, you can run the same pipeline. You also get table metrics, like I told you, we try as much as possible to incrementalize those materialized views, so you get output if that was successful. If it was not successful, like what's stopping the system from making this an incremental materialized view, etc. So there's much more. And well, you're welcome to try. As I said, I'm sharing a QR code later where you can sign up for this free edition. You don't need a credit card. Okay, now I said there's two more things I want to talk about. One is, first of all, going back to Spark and Spark streaming. Another thing that is not directly related to, let me change to the slides actually, that is not directly related to SDP, but it's merging together, is the real-time mode we have in Spark streaming. So a lot of folks said, I love Spark because of, the batch processing, the big data, the scalability. I also love it because it's just fast enough for, like latencies in, typically we had like seconds. Like I was trying to do something real time in quotation marks. That was 2 years ago. I had a small app where I kind of ingested mobile data, like the data from your sensors on the phones from a group of like 300 people in the audience. So they access a web app where you allow, to use your sensors on a mobile phone, and then it would send the sensor data, like how you hold the phone, how you move the phone, if you shake it or not, to Kinesis shot, and then use Spark streaming to do aggregations and like what's the average movement people do, like hold it still, move it a lot, like what's the maximum movement they can do. And when I was doing this 3 years ago, we got it to like 4 seconds. So all the real time was like not really real time, and I was told, marketing, don't call it real time if it's 4 seconds. If your ABS in your car or motorbike would be 4 seconds, you would not be here. So don't call it real time. Now people said, yeah, I mean, for most business application, that's good enough. But what if we need real time? Then what should we do? Go to Flink and have a second system? Then define real time goes there, and otherwise we want to stay with Spark. Well, long story short, now there is real time mode in Spark. So you can get down to the order of, actually here it says hundreds of milliseconds. It can be much lower than hundreds of milliseconds. So what you can do is just set a different trigger, and then Spark switches to real-time mode, which is a different internal processing. It's using more CPUs. It's doing more things in parallel, and it's trying to optimize and then write less checkpoints. And this gets you down to double-digit milliseconds. And you probably say, well, the small example you showed us was really cool. Hopefully you say this. You say, the small example, Frank, you showed us with 4 lines of code, and then we got all the live data from all the planes. It's really cool. But it's still like a hello world example. Where's the real thing? Now, I'm showing you the real thing, but the real thing has a problem, and apparently it's not working with this network. So I switched to my phone, which is something I never wanted to do in front of an audience, but let's see if that's working. Okay, let's see if we can just get to this page. So, same story, same technology, Spark streaming, not SDP, but the underlying Spark streaming. That's something our SAs, our solution architects, are currently doing. It's a live air traffic control system. They built with Spark streaming, real-time mode, using Kafka, reading from Kafka. Let me zoom this in. And you see it's moving, those planes are moving. They're not moving like crazy fast because this is how planes move on such a scale. But you can kind of click in and see these congestion zones, and you see like the speed leaderboard, you see these alerts. And that's literally something they're currently working with I can't give you the customer names because they're just prospects and not customers. But one is like the biggest airport at this lovely country where they have the good coffee shops with the nice cookies. The other prospect is the, how do I say that? Well, maybe the only and the biggest defense organization we have in Europe. I still don't know how I would paraphrase this if I ever do this talk in the US. And the other one, the other third really big customer, they're working on the similar story, is the biggest port we have in Europe. So it's a big thing. It's happening right now. It's the same technology used on a enterprise scale. And that's what I wanted just to show you. Now, here I went one step back. I told you this is not SDP yet, but it's the underlying Spark streaming. It is coming to SDP as we speak. So if you go for the free account, there is the classic, there's two channels for the SDP pipelines. One is the production channel and one is the preview channel. If you switch to preview, you can already try RTM with SDPs. And then you get the combination of both, and you could code this application not using Spark streaming, but SDP. Okay, then one more thing. If you read the abstract, you know, we have to submit these abstracts, and then time passes, and then we're here to present. Like in the abstract, I said, I can live code this. Well, the thing is, I can live code this because the code for first of all, if you just go getting started, with Apache. The important thing is, if you search for something, always search for Apache SDP, Spark Declarative Pipelines, and not SDP. There's like 20 different acronyms with SDP, from Socialist Democratic Party to, well, you probably know some of the others, like spec-driven, whatever. I built that page, and I'm super happy. It's picked up really well by all the AI systems, and it's also picked up really well by Google. So if you click on that, you get to this page. Don't care about the cookies. You get to my fun animation that I vibe coded. You get a small explanation, pipeline, streaming tables, materialized views. But then you get to both examples, the open source one and the other one. Let's click on the open source again. And just to review, it's literally what you need is this YAML file. Then what you need is that streaming table file at dp table, Spark read stream OpenSky, plus the plumbing thing to get the data source registered. Then any aggregation will do. You can have one line, count star s number of events, and then you're done. So this is why I said you can run this example in your coffee break. Now you can say, well, Frank, you still didn't live code this. The question is live coding still a big thing if we have AI generating this? So the real question is, you should ask me, and I'm going to answer it before you ask me, how can we generate this with AI? Well, there's two things. One is, well, there's two things in addition to the obvious. The obvious is probably Claude Code or Cursor or whatever you want to use. Two things. One is, and marketing will kill me, not you, of course, will kill me for showing this in the wrong order. But we have something open source. It's called AI DevKit Databricks. It's our SAs have built that. It's amazing. It's a skill addition to Claude Code. You install it with Databricks AI DevKit. You install it with a single line, the classic bash, blah, 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 from curl something. And then, let me go here. No, where are we? This is it. Okay, so that's my Claude already having this installed. And then you can basically use Claude Code and say, generate me a streaming table, generate me a pipeline with a streaming table with a materialized view. It works for all other components within Databricks. You can do data warehouses, you can do delta tables, you can do all the AI stuff, like agentic stuff. You can do simple things like, list all pipelines, and it will also kind of remote deploy to your workspaces. Let's see if that's doing something. Come on. Well, it's probably burning 3,000 tokens just to get a list of all my SDP pipelines. But since I'm here, let's do it. It's not worth all this time waiting to see the list of the pipelines. I'm pretty sure it does it. Okay, let me do one thing in between that is actually even cooler, and that might take 2 to 3 minutes, and then I switch back to this. Where am I? I want to go back to my... Yeah, so this is the free edition account. It's literally my Gmail free edition account. Something that is maybe a little bit easier for the folks who are not used to terminal and not used to Claude Code is the built-in thing that we have in this free edition. So you could go just here and say new ETL pipeline. And then you just get a new pipeline, and you can start, just say here, plus give me a transformation, which could be streaming table materialized view, create me a test, etc. But you could also say just go to Genie code, and Genie code is kind of the built-in system, which is the equivalent of Claude Code, but just built in. And then here I want to have a new session. And then something I told you, another open source project that we pushed is Unity Catalog, which is this governance system that works across tables and, well, everything, AI agents, but also pipelines and everything. So that's the Unity Catalog view. And if I go to Catalog, you see this existing catalog, and we have samples. And there is a demo data set. It's called Bakehouse. Our team built this like 2 years ago because we didn't have anything to play with, and then it became incredibly popular. So what I wanted to show you is and that's maybe the frustrating thing I leave you with. What I wanted, oops, that was not good. What I wanted to show you is this. Let's see if that's working. Create a data pipeline. Let's see. Yeah, that works. Sorry, I can't zoom, then I'm not seeing this. Took the OK. Now it stopped working. OK, I can type, no problem. So what I say is create a data pipeline, maybe a SDP data pipeline, reading from samples Bakehouse using an MV for analytics. Okay, that was a dumb sentence, almost like middle manager level imprecise. But if you just do this, it will spin off. It will find the correct data sets. It will ingest them using streaming tables. It will then kind of join them. It will create a materialized view. So it will basically do everything, like the core pipeline from streaming tables, materialized views, accessing the data, doing a demo join, creating the pipeline, dry running the pipeline, running the pipeline. So this is the state of AI where we are today. And even if you misspell, the catalog name, here it says, look, I found the catalog. I see these tables. Then it's typically probing the tables and says, look, let me check how the data looks like. It says, do you want me to build a medallion architecture, simple analytics MV versus medallion architecture? I would say option 2, and then just let it run. So all the basic scaffolding, all the basic, templating, that was the challenge like a year ago, 2 years ago. Like my job was building small demos because nobody else could do it. Now everyone else can do it, but a lot of people don't really understand what they're doing using AI. But it has changed a lot, and that's also the takeaway here for you. So if your job today is, creating those core pipeline things, it will change in a dramatic way. Because Genie Code is able to do it, the AI dev kit is able to do it. So one takeaway here is learn the basics, like what we did today in 40 minutes, but then also learn how to apply AI, and then maybe focus on the higher level problems. I didn't talk about data quality. There's data quality constraints we can apply in SDP. We can say, look, if something doesn't match, what to do? Should we lock it? Should we stop the pipeline? Should we drop the row? All this is possible. So there's many more things possible. And with this, I want to end. A few seconds left for questions. Well, it's been a very good audience. Thank you for being here. Sorry for my bad voice. I'm just recovering from a cold, trying not to cough into the microphone. Any questions? I'll be around. Let's take one live, please.
So does the SDP use behind the scenes the same Spark optimizations, and is it the execution plans is visible within the Spark?
Yes, exactly. So here I was never defining a cluster. It's running on serverless infrastructure in Lakeflow. It's using the underlying Spark streaming, so everything. It depends. If you go open source, everything that exists for Spark streaming exists. If you go Lakeflow, the optimizers that we have will apply the same way. Yeah. It's the same underlying system. It's like, sometimes I say it's like, Spark streaming is like the cars with the stick shift, where you want to have the manual control, which used to be the default thing. Like when I was young, and now automatic cars. When I was young, automatic cars were for boring old people. Now everyone is driving them because they're so good. And I think SDP is the same thing. If you start with SDP, it's just much easier. You don't care about concurrency, about checkpoint locations, about retries, and about all this, about the scheduling. And so SDP, definitely, if you start. There's lots of people out there still doing Spark streaming. We kind of neglected them a bit just by pushing out this marketing message. SDP is the new shiny thing. If you have 10,000 Spark streaming jobs running, you don't need to switch them off or migrate them. You don't have to. And there's always these 3%, 5% where you probably don't want to go with for SDP. Spark streaming is still the solid underlying platform. Yeah. Thank you for being here. Thank you. Please rate the talk. Happy to get feedback. Connect to me on LinkedIn. I try to be a friendly person. If you need anything, like I'm sharing the slides on a speaker deck, anything, just contact me. Thank you.